Hello, everybody. In my statistics class, this is Professor Ken. And look, I'm at the world's largest waterfall, Angel Falls in Venezuela. I've actually been there before. It's beautiful. Anyway, I just wanted to go over a quick review about a few things. So first of all, I did already make a video showing you how to do a null hypothesis test to test a proportion and a null hypothesis test to test a mean. So I'm not going to cover those in this video because you have a video on that already, and that would be superfluous. Good word. All right. So first, I want to kind of go over with you some basic background about null hypothesis testing. So in order for me to do that, I'm going to share my screen. And now I'm going to, I got this bar in the way that you can't see. Okay, so I'm going to open up my whiteboard. Takes a minute. Here it comes. Yeah, I'm going to make a new whiteboard. All right, so what we're going to do now is a little background on some null hypothesis testing. All right, so when we're testing a null hypothesis, we're going to have our null hypothesis, and we're going to either test the mean, the standard deviation, or the proportion. So if we're testing the standard deviation, for instance, we're claiming that the standard deviation equals some value, say 10. Now, the alternative hypothesis is that the standard deviation doesn't equal 10. It could be greater than 10, less than 10, or not equal to 10. Let's say not equal to 10. All right, now, there are some very important numbers that you have to calculate or find on a chart, in Desmos, etc. So if we know the distribution for a standard deviation is going to be chi-square. So I'll put the chi-square over here. And the second axis that we're testing is standard deviations of a mean, which we'll call S. I'm sorry, standard deviation of the sample, which we will call S. And we'll have a little S axis here. All right, so now we're testing this with a significance level, and the significance level determines the area of the tail. So since this is less than, right here, it's going to be a left tail test. If our significance level is 0.05, then that means the area of the left tail is going to be 0.05. And this would be 0.95. All right. Now, the first number I want to introduce you to is called the critical value. The critical value is the chi-square number that lines up with the partition. So this is our partition. We'll call this, suppose the critical value is 18. Okay. Now, the next important number, so this is called the critical value. I'm going to even highlight a little bit there, critical value. Okay. Now, as soon as we have our critical value, we know the parameters of our test. So if now we're going to be let me back up a little bit. Okay. Now we also have our sample. So we've tested a sample, and from that sample, we got a sample standard deviation, which we'll call S. Suppose S might be like 9.2. All right, that would be right here. Okay. We need to convert that 9.2 into a chi-squared score. And we're going to call that chi-squared score chi-square. Now, if the chi-square score, which is the score that it's called the test statistic, if our test statistic falls in the tail, then we reject the null hypothesis. If the test statistic falls outside the tail, we fail to reject the null hypothesis. But what we need to do is find out the value of that chi-square and see where it is on this axis. So the parameters are if chi-square is less than, we said 18, then we reject the null hypothesis. If our chi-square is greater than 18, we fail to reject. All right, so once again, our critical value is 18, and then we have our test statistic. Let's suppose our test statistic, we run it through that formula, and it comes out to be 17.2. Well, we see that our test statistic 17.2 is actually in the tail. So we would reject the null hypothesis. If our test statistic is in this area, we would have failed to reject. But since it's 17.2, we reject the null hypothesis. Now, what does that mean? Now, if we reject the null hypothesis, then the alternative hypothesis is true. Plain and simple. If we fail to reject the null hypothesis, then the alternative hypothesis is false. Let's just think about it like that for now. Now, what does that mean? So in this case, our test statistic is 17.2. It falls in the tail, so we reject the null hypothesis. What does that mean? Our alternative hypothesis is true. So what's our final interpretation? The standard deviation is indeed less than 10. What if the test statistic was 18.9? It would fall here. We would fail to reject. Now, what does that mean? Our explanation is a little different now. We don't say that we've proven that the standard deviation is equal to 10. We haven't. All we can say is that this is not true. So we say we do not have enough evidence to prove that the standard deviation is less than 10. Okay, so now it doesn't matter whether it's a left-tailed test or a right-tailed test or a two-tailed test. It doesn't matter if we're testing the standard deviation, the proportion, or the mean. We're always going to have tails, and the tails are defined by the critical values, and we're always going to have a test statistic. And if the test statistic falls in the tail, we reject the null hypothesis. If it doesn't, we fail to reject. And, ooh, I didn't mean to do that. And we're always going to have two axes. Now, if it's a null, if we're testing standard deviation, it's going to be chi-squared and standard deviation. If it's mean, it's going to be t and x bar. If it's going to be proportion, it's going to be z and p. Okay, so I hope this is helpful for you. All right, so now we're going to do a couple examples. Well, now we're going to do one where we're testing two means. I'm sorry, two proportions. All right, so what I'm going to do is I'm going to add a text box. All right, and I don't know why the text on the text box is so darn large, but ooh, what happened to it? Okay. Shit, darn it, just went away again. All right. Let me try one more time. It seems like I can't get rid of this menu, even though it's in my way. Okay. Now, let's try this. All right. 23% of dogs do not survive getting hit by a car. 28% of squirrels do not survive getting hit by a car. Wait, we've got to go see out of a sample of 150, and the squirrels out of a sample of 81 do not survive getting hit by a car. Okay. Test with 0.05 significance whether more squirrels are killed when hit by a car compared to dogs. Okay, so there's our problem. Now, what we're going to do is we're going to take some notes. We'll call that step one. So in this problem, all right, we have some information about dogs and we have some information about squirrels. And, whoops. Scroll down just a little bit. I wish I could have made that smaller somehow, but I cannot. All right. So with the dogs, we have a proportion, which we'll call P1 hat. And that's equal to 0.23. We also have our sample size, which we'll call N1, and that is 150. Now 150. We also have to have our success rate for dogs, which we call X1. All right, now the number's not given, but we do know that it's 23% of 150. So we can go to Desmos. Find out what's 23% of 150. So 0.23 times 150 is 34.5. We'll call it 35. All right, now for squirrels, the p hat 2 is equal to 28%. The sample size of the now notice I put it as a decimal. You can't put just 28. All right. The number of squirrels we tested is 81. And if successes, we're defining successes getting killed by a car. So that's 28% of the 81. I apologize if that grosses anybody out. So 28% times 81, 22.68. We'll round that off to 23. All right. And we know our alpha level is 0.05. Oops. Okay. So now we're ready to write our null hypothesis. Well, actually, we need to say what kind of tail this is going to be. It's going to be, well, we're saying that squirrels are greater than dogs, so the proportion for dogs minus the proportion for squirrels is going to be less than 0 because we're saying the squirrels are bigger. So that would be a left tail test. So it's a left tail z-test because it's proportions. Okay, so here we go. The null hypothesis is that the proportion of dogs that are killed when hit by cars minus the proportion of squirrels that are killed when hit by cars is equal to 0 because the null hypothesis is always equal. Step 3, the alternative hypothesis. Now we're saying squirrels is bigger. Since P2 is squirrels, P2 is bigger than P1. So when we subtract it, we would get a negative number. Okay, is less than 0. All right, now for 4, we have to give our alpha level. Our significance level is, did we say 0.05 or 0.01? I forget. 0.05. Okay, great. All right. Now we're ready to draw a picture a little bit. Okay. So this is step 5 and 6. So there's our curve. It's a z curve. Down here we have the p-value. So right here we have P1 minus P2. And we're saying that that's equal to 0. All right, since we're saying that P1 minus P2, the alternative is less than 0, it's a left tail test. The area of the left tail is 0.05. So this area is 0.95. Now this is important to remember. We're also talking about the area to the left of the partition when we have to figure out our critical value. So let's go to Desmos and pull up the correct test and see if we can get our critical value. So it's 2 proportions. So it's a normal distribution with 5 significance level, but we want the minimum to be negative z, but we don't want to have, there's no right tail, so we'll type in infinity. All right, now our area is screwed up. We want 0.95. So what we do is we just take away the divided by 2. We divide by 2 when it's a 2-tailed test. All right, so what was P1? I'm going to have to maybe go back and forth a little bit. Roll up. Okay, P1 is 23. Is 23%. So T1 hat is 0.23. That's what that means. What's P2 hat? 28%, 0.28. The Q1 hat and Q2 hat are done for us. The N value, well, for the dogs, we had 150. And for the squirrels, we had 81. How many dogs were killed? Sadly, 35. How many squirrels were killed? Not so sadly, 23. All right, now we use this lovely formula and this lovely formula and this lovely formula to get our test statistic. However, at this point, we need our critical z value, and here it is, 1.64. Now, we have to be smarter than Desmos. Since it's left tail, it's going to be negative. So our critical z value is 1.64. Negative. And our test statistic z, let's go back and look. Here it is, negative 0.84. Now, I'm not going to finish the null hypothesis test because that's all formality and I don't want to waste your time. I know you know how to do that already. But let's take a look at where our test statistic falls. Well, here's negative 1.64. Here's values less than negative 1.64. Here's values greater than 1.64. This is greater than 1.64. It falls in this area. So we're going to fail to reject the null hypothesis. What does that mean? It means this is false. Now, if this were true, the percentage of squirrels killed by cars is greater than the percentage of dogs killed by cars. But since it's false, what do we say? Well, here's what we say. We say with 95% certainty, we do not have enough evidence to prove that the percentage of squirrels killed when run over by automobiles is greater than the percentage of doggies that are killed when run over by automobiles. So there's the two-tailed p-test. And I hope, and I already went previously showed you about the testing the standard deviations with the null hypothesis test, but I suppose I can do one of those problems for you as well. I suppose it won't hurt. All right, so let's scroll down. I'll do the abbreviated version. All right. So a study showed that 89 nurses tested the blood pressure of the same patient. The systolic pressure had a mean of 120 millimeters of mercury and a standard deviation of 2.3 millimeters of mercury. All right, now we don't want to have a big standard deviation. We want to be the bigger the standard deviation, the less accurate these nurses are at measuring blood pressure. So, according to the health department, the standard deviation should not be greater than 1.8 millimeters of mercury. Test with 0.99 confidence, no, 0.01 confidence. If the standard deviation of nurses of measurements is greater than 1.8. Okay, here we go. So let's take some notes. Okay. So first of all, our sample standard deviation was 2.3. The standard deviation of the population is supposed to be 1.8. Our sample size was 89. All right, so we're testing to see if our sample is greater than the 1.8. So that means it's going to be a right tail chi-square test. So what is the null hypothesis? Is that the standard deviation is equal to 1.8. What's the alternative hypothesis? Is that the standard deviation is greater than 1.8. And our alpha level or significance level is 0.01. All right, let's get ready to draw. All right, so this is going to be a chi-square curve. It'll look like a roller coaster hill or a whale, depending on whether or not you are landing. So here's chi-square. Here's standard deviation. So our standard deviation was 2.3. That's what we're testing. 2.3. And it's a right tail test. So this area is going to be 0.01. This area is going to be 0.99. Now, keep in mind, the area to the left of the partition is 0.99. That's what we're going to be looking for when we enter our data. All right, so now we're going to go to our Excel file. Null hypothesis test with standard deviation. Okay, there it is. All right, beautiful. All right, so our sample size, I'm going to have to scroll back and forth because I have bad memories. Was 89. Our standard deviation was, I believe it was 2.3. Yeah, the standard deviation of the sample was 2.3, and the standard deviation of the population is 1.8. Now, right alpha, what's going to be the area to the left of the right partition? It's going to be 0.99. What's going to be the area to the left of the left partition? Well, there is no left partition because it's only a right tail test, so we can put a 0 in for that. All right, so our right critical value is 121.8. So we could draw that in. 121.8. And then we have to convert 2.3 into a chi-square value. Now, if that chi-square value is bigger than 121.8, we reject the null hypothesis. And the converse is also true. If the chi-square value is less than 121.8, we're going to fail to reject. But I'm not going to write all that because you know that already. All right, let's go find out our chi-square value. Our chi-square value is 143.7. So chi-square equals 143.7. I believe I said it correctly. My memory, 143.7. All right, so where does it, is it in the tail or is it not in the tail? Oh my God, it's in the tail. That means we reject the null hypothesis. So then we go to our alternative hypothesis because we've proven it true. So that means the standard deviation for those 89 nurses is indeed greater than 1.8. We've proven it. So what does that mean? They stink at taking blood pressure. They need more training with blood pressure, how to take the blood pressure and not screw it up. All right, I'm going to stop my share. So what do we do in this little video besides learn about Angel Falls? We reviewed the the basics behind null hypothesis testing and what we do with it. I gave an example of testing two proportions, and I gave an example of testing a state for a standard deviation. And you remember, you have another video that shows you how to test for a proportion and for a mean. So I don't know what else I can do for you people. Well, I suppose there's lots on the YouTube that you could find if you need further information. But I think with all your notes that you have and with these videos, you're ready to do the assignment, which is 4 standard deviation problems. You're going to hand it in a hard copy on Thursday, and it's going to be graded out of 40 points. And that should, for those of you who did Stinkhole on the quiz, should help your grade, help boost it up. Okay, this is Professor Ken signing off.